Hello and welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.4, problem number 31. So we've got a half-life problem. It's bismuth 210, and the half-life is 5 days. So we've got parts A through D. It'll be a little bit of a longer problem, but that's okay. We'll just take our time and we'll get through it just fine. So, let's go ahead and get started. The first thing that I want to say right off the bat is there's a type of equation that I want to use. I don't think I saw it in the notes for 1.4, so I'm not sure where it went, but you've probably seen it before. If not, then I'll try to introduce it as best as possible. It's called, sometimes people nickname it PERT. It's the following equation. It's P equals P initial times e to the RT, and this is similar to the function f of x equals c times b to the t, where in this case b here is equal to e to the r. So all you're really doing is you're just manipulating the function a little bit so that you have continuous growth or continuous decay. In this case, with decay, right? Something's always decaying or always growing. There's no slight intervals or anything like that. It's just, it makes everything a little bit smoother. I like to work with e to the r as opposed to just b to the t. So we're going to use this, and I'll show you what all of these variables mean. P, right here, this is final. P sub 0 is initial. That's your starting amount. So I'll say initial or starting. E, that's just the number E. R is a rate, some constant rate. And T is time. And the time can be measured in anything. It could be seconds, minutes, hours, days, anything really. You just have to make sure that you adjust for that and you're always using the same unit of time for T. So that said, I'm going to erase this f of x equals c times b to the t, and let's go ahead and get started. So we have half-life of 5 days. Let's write that down first. So what does that mean? That means that every 5 days, you will have half the mass of the amount. So for part A says you have 200 milligrams. And what's remaining after 15 days? Well, we know that every 5 days, it will be half that mass. So here we go. We're at 0 days. Well, let's see, let's just orient this a different way. So 200 milligrams, this is in milligrams, and this is in days. So we have 200 at day 0. Then we have 100 at day 5, 50 at day 10, and 25 at day 15, okay? So our answer for part A is 25, nice and simple. Good, okay. Now for 31, part B, find the amount remaining after t days. So what they want is they want us to actually make a function. So we can do that using the half-life. We know that t is measured in days. So we have, let's say we still start with 500 and we have 5 days that pass. So we'll have 250 is equal to 500 times e to the r times 5. This is the same idea as this equation, P equals P initial e to the RT. Okay? So let's go ahead and divide both sides by 500, and we'll get 1/2 equals e to the r 5. Or we could even switch it and just say 5r. It's just a more comfortable way to write that. Okay, well, let's do ln of both sides. So ln of 1/2 is equal to ln of e to the 5r. One of the properties of logs is that we can draw the exponent down and make that a coefficient. So now we have ln of 1/2 equals 5r ln e. And ln e is just 1, so that's done. Now we have ln, just to make this a little bit cleaner, I'm going to write 0.5 instead of 1/2. So ln 0.5 equals 5r. We'll divide by 5. And now we have r is equal to ln of 0.5 all over 5. Okay, so now what do we do with that? Well, now we can plug that in for our r value here, and we can make our general equation. So in general, p is going to be equal to 500 times e to the ln of 0.5 over 5 times t. Okay, so that's part B. Part C, find the amount remaining after 3 weeks. Well, 3 weeks, that's the equivalent of 21 days. So since this is measured in days, we want to make sure that we're consistent with that, and we have our answer in days. So we'll have P equals 500 e to the, it's a lot to write, but it's good to do, ln of 0.5 over 5 times 21. Okay, now we'll go ahead and do our math, and let's see, this is, had a different bracket here. So I'll do the exponent part first. So we have, I'm typing into the calculator ln of 0.5, then dividing by 5, multiply by 21, and now I'm going to take e to that power. So e to the power of that answer, and then I'm going to multiply that final answer by 500, because that's what we started with. And we get just about 27.20. Now wait a minute, where did I get this 500 number from? I'm sorry, the 500 number was just some arbitrary number that I chose. Let's go ahead and, that number doesn't make sense. It says in the problem that we started with 200. So let's go ahead and redo that. We'll have 200 times e and all of that. So all I'm going to do is just divide again by 500 and then multiply by 200. Then we'll get the right answer. So we'll multiply by 200. There we go. Now we get 10.88. 8818 and all sorts of other decimals. We can just say about 10.88, and this is measured in milligrams, correct? Yes. 10.88 milligrams. Okay, good. So that's that for part C. Again, I'm sorry for giving you the incorrect starting amount. I was just using some arbitrary half-life, suppose we started with 500, we would end with 250. The ratio is the same. It doesn't matter what we start with. We could start with 2 and 1, or we could start with 4 and 2. The ratio is always going to be 1/2, so again, sorry about that, but anyways. Next thing that we have, there's just going to be a little bit of noise because it says to use the graph to estimate the time required for the mass to be 1 milligram. So here we go, just getting the keyboard all set up. And what's our function? It's 200 e to the ln 0.5 over 5 times t. So we have y equals 200 e to the ln 0.5 divided by 5 times t. There we are. And we need to figure out when this equals 1. So actually we should stretch this back out and compress the x-axis. There it is. Looks like it will equal 1 after 38.218 days. So we'll write mass equals 1 at about, it was 38 point, I think it was, what was it, 38.218? Yeah. And that's going to be everything for part D.